Alright, this is the second part of the Trigonometrics function series. In the first video we learned how to perform trigonometric functions using SOH CAH TOA, which is the sine, cosine, and tangent function. And the purpose of those functions, again, was to help us figure out the sides of a triangle. If we knew what the angles were, then we could use those functions to figure out what the hypotenuse and then the adjacent and the opposite side were, depending on how we named the triangle. And remember, you name the triangle based off of one of the angles inside, and that's your choice, whichever angle you want. Well, now we're going to talk about the inverse trigonometric functions, and that helps us figure out what the angles are if we know what the sides are. So it's just the opposite of the first video. Okay, so let's go ahead and try and figure out what theta 1 is first. Obviously, we know that this box here means 90 degrees. This is a right triangle. I haven't taught you how to do anything trigonometric function-wise on a triangle other than a right triangle, and I'm not going to. Okay, so let's figure out what theta 1 is. We need to name the triangle based off of theta 1. So let's see if you can do that. Obviously this 48 meters up here is going to be the hypotenuse. So we will label that hypotenuse. What is the x going to be? What would that be named based off of theta 1 here? What would x be called? The opposite side. And then we have the 10.2 meters down here. What would that be called based off of theta 1? What would the 10.2 meters be? That would be the adjacent side. Okay? Alright, so I think the next thing that we need to do is go ahead and write SOH CAH TOA down. That's what I asked you to do every time that we work one of these triangle problems, just so that we can see what functions we have available to us and what we need to know in order to use them. Okay, so I said at the beginning we're going to solve for theta 1. Okay, notice that the side opposite of theta 1 is a value that we don't know. So it's really not going to help us to use a function that has opposite in it. So that means we can't use the sine function and we can't use the tangent function. So the cosine function is the one that we're going to go for. Let's write that out. The cosine of theta is equal to the adjacent over the hypotenuse. Alright, that's the normal function. Okay, now it requires that you know what one of the two sides are here, or both of them really, the adjacent and the hypotenuse. Okay, and that would tell you what the value of the cosine of the angle is that you're looking for, but we want to know just the angle. Here's where the inverse part happens. If you want just theta, then you can say theta is equal to the inverse function. So the cosine to the negative first power, the inverse of the adjacent over the hypotenuse. That will tell us what the angle theta is. So for us, and remember we're figuring out what theta 1 is, so theta 1 is equal to the inverse cosine of 10.2 divided by 48. Okay, now notice I do have meters in here. We're going to keep track of all of our units every time we work a problem, but you'll also notice that meters divided by meters cancels out. Okay, and it's really important to remember that theta is an angle. So what would the unit be for theta at the end of this problem? What are angles measured in? Degrees. Alright, let's type this into our calculator. And when I do that, and make sure that your calculators are in degree mode, When I do that, I get 77.731101 degrees. Okay? Now we just need to be concerned with significant digits. Alright, so let's go back and look up here at the information that we were given. For our sides, looks like 2 sig figs is the most on the sides. And then on our angles, 90 degrees is a number that has no decimals, so we would start counting on the right hand side and find the first non-zero digit, which is 9. So that gives us 1 significant digit on our angles. Alright, so how can we write 77 with 1 significant digit? That gets us to 80 degrees. And we got there because this 7 rounds this 7 up to an 8 and becomes a 0, and now this is a number with no decimal and only 1 significant digit. Alright, so theta 1 is going to be 80 degrees. Now remember, that's rounded, alright? When we do other calculations, we'll need to use this longer, more accurate, more precise answer. Okay? Now, you could go ahead and solve for theta 2 right now, just using properties of a triangle, that all the interior angles have to add up to be 180. Let's go ahead and do that and just see what we get. We can say that 180 degrees is going to be equal to the 90 degrees on the inside plus the theta 1 value plus the theta 2 value. Okay, so if we want to get theta 2 by itself, then we'll have to subtract 90 and subtract theta 1 from both sides. Alright, so those go away, and then we have 180 minus 90, which is 90 minus theta 1 is going to be equal to theta 2. Now we can go ahead and plug in this value for theta 1 here. So we're going to have 90 minus 77.731101, and I should have degree signs on all of this. It's going to be equal to theta 2, and that means that theta 2 equals 12.2688899 degrees. Alright, so theta 2 with significant digits would be 10 degrees. And so that adds up correctly. We have one angle of 90 degrees, that's half of our 180. Then we have theta 1 80 degrees, theta 2 10 degrees. Together that gives us 90 degrees, which is the other half of 180. So that process worked out correctly. Now let's go ahead and find theta 2 using our inverse trigonometric functions. Alright, so now we want theta 2. So we have to rename our triangle based off of theta 2. So this is no longer going to be the adjacent side. This is going to be the opposite side. And this is no longer going to be the opposite side. It'll be the adjacent side. And of course the hypotenuse stays the same. Now, since we want theta 2 and our adjacent side is an unknown value, then we want to make sure we don't use anything that has adjacent in it. So that means that the cosine is out and that the tangent function is out. So we're going to use the sine function to figure out what theta 2 is. So let's go ahead and write that down. We have the sine of theta, and we'll go ahead and say theta 2 is equal to the opposite side over the hypotenuse. Now again, we want to know what just the angle theta 2 is, so we'll need to use the inverse sign. So we can say theta 2 equals the inverse sign of the opposite value over the hypotenuse value. Now let's plug our numbers in. Alright, so the new opposite value is our 10.2 meters, because we renamed our triangle, and the hypotenuse stayed the same at 48 meters. Again, meters cancels meters, so we're ready to plug this into our calculators. Alright, and when we plug that in, we get 12.268899 degrees. Exactly what we got when we just did the subtraction. So again, theta 2 with one significant digit is 10 degrees. Exactly what we predicted, and our triangle works out correctly. Okay, so the last thing that we're going to do, just as a review, is figure out what this side x is over here. Alright, so you should know how to do this, and you should know that there are two ways to do it. You could use the Pythagorean theorem. Since you have two sides of the triangle already, you can figure out what the third one is based off of that. Or we can use our trigonometric functions to figure it out. Let's go ahead and use theta 2 as the angle this time. I'm just picking that one. You could pick theta 1 to figure this out also. That doesn't matter. So I'm going to pick theta 2 to figure this one out, which means the triangle is named in this direction, that this is the opposite and this is the adjacent. We're trying to find the adjacent side, so we need a trigonometric function that does have adjacent in it. That brings us down to the cosine or the tangent function. The cosine function requires us to know what the hypotenuse is, and we do. The tangent function requires us to know what the opposite side is, and we do. So it makes no difference which one we choose. Let's go ahead and choose the cosine just for fun. So we have that the cosine of theta 2, because that's the one we chose, is equal to, it's a bad equal sign, the adjacent side, which is the one that we don't know, over the hypotenuse, which we do know. Alright, now it's x that we want to figure out, so we're going to have to multiply both sides by 48. These cancel out, and we're left with x is equal to 48 times the cosine of theta 2. And theta 2 is the 12.268899 degrees. And remember, anytime you do a trigonometric function, your calculator has to be in degree mode. So when we type that in the calculator, we get 46.903731119 meters. And meters because this is a length, it's a side. Okay, so now let's write that with sig figs being correct. And remember, we decided earlier that 2 sig figs was the maximum that a side could have. So looking at our answer here, there's the first sig fig, there's the second, but you have to look one place value over and see, does the 9 do anything to the 6? And yes, it does. So our final answer is going to be 47 meters for side x. Alright, that's all for today. Thank you for learning with me, and I'll see you next time.